I know it sounds weird, man, but this little stick that it's got rivets in it. You go, and when you do that, like it tricks the worms to thinking that there's a burrowing creature going into the ground.
Really? Yeah.
And the worms come up to the surface. But once you get worms, you can get fish, you can get bird, and then you can work your way up. And instead of hunting, you should agriculture, try to keep them alive as long as possible, mate them. You know what I mean? It's not a kill mentality that we need. We need to work together. We need to understand how to get through these times if they were to happen.
Yeah. Like I know Gerald's been working on the electroculture and stuff like that. I'm a big supporter of that kind of stuff for sure.
Absolutely.
Yes. Yeah, it's very cool.
Yeah. I'm just going to show the video I did today at my locker, my power system. Just bear with me here for a second. Hey everybody, welcome back to Faraday Research. It is Friday morning. Happy Free Energy Friday. We have our live show tonight. You can tune into the show at Faraday Research. Just click on the live tab and we'll be going to live to air at 10 o'clock Eastern, 6 o'clock Pacific. And so I'm in the locker today. I'm doing work. I'm building the power unit for the locker. And as you can see, I got my friend's power unit running. I'm running a fan right now because it's getting pretty hot out. So you know what? I figure I got to drain these batteries down so I can do some charge testing with it. So I got this fan. It's going full blast. And I'm just going to let it run pretty much all day. I have to wear these batteries down. And then I'm going to hook up the solar panel to it. I got the 400 watt solar panel, so I'm going to do some charge testing next week. But anyways, so far so good. Everything's running great. Power cables are cold. If you haven't subscribed to the channel, bottom right hand corner, also give me a thumbs up at the end of the video. So as you can see, I've joined the two batteries together. I'm using 1 gauge power cable. So they're all crimped. They're all shrink wrapped and everything. Very professional. Rock solid. This thing will never fail. So they got the BMS inside. So if they were to overheat or whatever, these things will automatically shut down with the BMS inside. They'll shut them off in 10 minutes. So I got that on the go. My saw is working great. I've had to use the saw. As you can see, I got the nice baffle board here that I've made. And I've got the nice material on it. And this is going to fit right on top here like this. Just bear with me for a sec. There we go. So now we got our panel here. Rock solid. Ain't going anywhere. Got the nice felt in it that I put in the other day. I might have to glue a little bit on the edges, but other than that, everything turned out beautiful. So I also ordered my new 2000 watt Renogy inverter, which is the same one as my friend. So I got a good deal. I got this for $329. So that was a great deal. So I picked one of these up. And if you bear with me here for 1 second, I'll show you how it fits. I hate doing this, but sorry. There we go. So I got it in here. Fits perfectly. Now, the great thing about this box is this will close right up now. So completely concealed unit. I'm the receptacles are on the side here. So I might make an extension and put it, say, like on a power bar along here. Put it on a power bar. And then I got my solar charge controller. I'm going to try this one out. This one's new. I've never really heard of this one. It's called the NNext Slim. So that's probably going to go in here like that. And then my my fuse is probably going to go in somewhere in this region here, because tomorrow I got coming in is the main power cutoff switch. And then I also got the fan. So I'm going to use the fan in this one because I'm going to probably run this unit with the lid closed. So it's going to need some air circulation inside. So we got the fan there, and that's going to be blowing towards the inverter. And then it's got the ribs here. So it should circulate the air quite well inside. So this is kind of like the layout, how it's going to look. Man, that looks sweet. Oh, God. This unit is so awesome. And this thing's working phenomenal. No problems at all. Rock solid. So it's just a couple things on the app I have to sort out. Some of the telemetries. It's not showing anything on the charge, but it's probably because the batteries are fully charged. The solar charge controller is not going to draw any more power into the system. So that's why I'm trying to wear these batteries down a bit. So when I do wear the batteries down, then the solar is going to kick in and start charging it up. So I have to use the system. So I got that fan blasting. I don't know. I think that's like 40 watts. I think it's like a 40-watt fan. So it can run pretty much all fucking day long. So, yeah. So I got my shop here. Got my new saw. This thing's awesome. Freaking love it. Best $200 I ever spent. And yeah, so I'll be working on this. I got the switch coming in tomorrow, and then I'll be starting to feed the wire in, how I'm going to hook it up. So I think this is going to have to maybe go here, and the switch is going to go in the corner. Ground cable will come up, connect to here, which is going to be a very short connection, which is good. Shorter the better, actually. And also the power cable is going to come in from the bottom, go through the switch, through the fuse, and then from the fuse to here. So it's going to be a very short connection to the thing, which is actually really good. Shorter the better. That protects you from any kind of thermal runaway. So yeah, the shorter the wires, the better. When it comes to a system like this, in all cases, that's not a reality. Cables might have to be a lot longer, but the shorter the cables are, the less resistance you have in your circuit. And that means a lot less chance of it overheating. So that's cool. So I think the wiring is going to work out just fine in this. The wiring for this guy, for the solar charge controller, I haven't decided if I'm going to put it on the front or I'm going to install it on the back. Most likely, I think I'm going to install the cables for this on the back. So if that's the case, then so be it. I got tons of room back here. As you saw earlier, I've totally encased the batteries. So the batteries are totally encased. So when you lift it up, they're not going to move. They're solidly secured. So that's a must. So yeah, this thing's, you could take this on the road with you. If you're going camping or whatever, you got a rock solid friggin' system that will run all your stuff you need for the entire weekend. So yeah, I'm really excited about this project. This one here is mainly for the locker. So I have power in the locker. Eventually this one's going to go to my buddy after I've done all the testing on it. Yeah, I'm trying to stay hydrated, have some pop, keep myself going. I probably.
Do you mind if I say anything? Is there audio?
Yeah, go ahead.
You're muted, Mike. Are you muted, Mike?
Yeah, sorry.
You had mentioned before, and you can cut me off and I won't say anything further, but you're sending the power through a diode, right? And you're charging a capacitor on the first stage.
No, we're talking about my power unit, or are you talking about the batteries?
I'm talking about, say you have 100-watt solar power, but by driving it with a relay, you can get maybe 300-watt.
Yeah, exactly. I'm going to make the dump circuit. So I'm going to take the solar panel, and I got the schematic for the dump circuit. So it's going to be directed with the diode.
I wanted to comment on that because I had heard you say that in a past live stream. I made this video. It was the boost bell. And what you do is you do exactly what you're saying, but add a low resistance inductor. And what happens is as it goes through the diode and the inductor, the magnetic field increases and then
Like a
collapses.
choke. Well, basically, you're saying a choke, right? A small choke.
It doubles the voltage on the capacitor on the first stage.
Okay, so would the choke before the capacitor or after the capacitor?
Yeah, say the battery, right? You go through a diode, through an inductor of low resistance, to a capacitor and back to the battery. Okay. What happens is normally if you short circuit that, it's an RLC of low Q and it will want to go back and forth, but because you have a diode there, it's prevented from going that back. Right. And what that does is it charges the capacitor to twice the voltage of it would have if it were just charged by the battery.
Right.
All you got to do is add a low resistance inductor and it through the diode, because you had that correct. And this is just my honest opinion. You know what I mean? You could try it both ways. Mm-hmm. But when you do that, if you double the potential on the capacitor, the energy storage squares, because the energy stored in a capacitor is the square of the voltage times the capacitance.
Right.
So just by doubling the voltage on that capacitor, it stores more energy off the bat.
Right. And then when you dead short it back to the battery, say you're charging, you could get 50 to 100 amps discharge in that.
That's where you're taking one solar panel and making it 2. And there's other things you can do to make it 3 or 4. You know, you get me though. Just try that. A low resistance inductor. I called it the mouse trap because what you're doing is you're pulling it back. Just like literally the mathematical equations of an inductor is like a mouse trap. And you're literally like, as the magnetic field's building, you're pulling this back as a torsion spring. And the release of that is the power.
It's like the snap. I mean, yeah.
And unless you snap the trap as quick as you did for the release, the power out's going to be greater. But who's stupid enough to be like, you know what? I'm going to set this trap as fast as possible. It's just a stupid analogy. You're not going to ever get more power out unless you try to set the trap at the same speed it snaps.
Right.
It's a timer.
Yeah, it's got to be timed correctly.
And when you double the voltage on the capacitor, you get 4 times the energy because it's square the voltage.
Right. Yeah, so I'll be using a 100 volt, 4,000 microfarad capacitor, and then I'll dump the energy that I'm getting from the solar panel into that. And
you said you're dumping it with a relay, right?
Yeah, a single throw relay, and
that's an awesome choice. I love relays. I was telling Nathan earlier, even though if you hit the bell like slowly, but if you're like really hitting it, like with a solid connection and solid open, like a relay is perfect for just slowly hitting it and letting it vibrate.
Like this will be really effective if you're using a lead acid battery, lithium, any kind of lithium battery or whatever. You got to be careful about that because it can affect the BMS.
Yeah, because you can have back. That's why I recommend a diode in the beginning, like you said too.
Yeah, there's going to be
just to prevent that.
Probably three diodes in this one.
But you could literally take a battery and an inductor and a capacitor and throw a switch, and it would sit there and go brrr until it dies down, maybe about 80 times, depending on the Q of the circuit. Right. So just by closing a circuit that has a capacitor and an inductor, the battery is going to be hidden with different voltages back and forth. It's going to be part of that circuit.
Yeah.
Just by closing it rapidly into an RLC circuit, you're going to get that vibration maybe about 80 times. Interesting. Just by doing that. You know what I mean? So but battery. Okay. Oh, sorry.
No, that's fine. Yeah, I'm totally on that. I'm gonna work on that probably in the next week or so.
Hey, Mike, nice clean build, man. It looks great.
Yeah, it's turning out really
I love how it all fits together like that. Your felt lid there looks beautiful. Everything's fitting nice, man. It's gonna be awesome.
Yeah,
It is a nice build.
Yeah, I want it to be durable, so if something happens, the power.
You know what'd be really cool to do with that, dude?
It definitely looks super durable, man. Like I wouldn't even hesitate to throw that in the back of a truck, rip it right out, plug some stuff in. Awesome, man. That's like putting it all to good practical use. I love that.
Mhm.
I think to demo it, dude, you should bring it outside, like wheel it, and then absorb water from the air and make water out of the air with.
Yeah, I have the circuit to make that too. Yeah,
that would be cool.
Yeah. Laser, what's his name? The guy from Plasma Channel actually did a pretty good build on that.
Yeah,
he did.
Yeah, but I had this before him. I mentioned it on Old Man Bills. I mentioned it on Old Man Bills.
But,
bringing water to the desert.
Yeah.
Yep.
Because everybody's seen the experiment. Well, hopefully you've seen the experiment with water coming out of the faucet, and you comb your hair with the comb, and you hold the comb next to the water, and it bends towards it.
Yeah, it's magnetic.
Water, especially like dew. Most people want to use the daytime to make water, but if you were to make water at night, you have let the sun evaporate the water during the day and condense during the night.
Right.
It's already more efficient.
Yeah.
It's already more efficient doing it that way.
Way more efficient. Yeah, exactly.
Well, they make a commercial unit already for that. You can put on your house. It makes up to 1 gallon of water a day.
A while ago,
that's awesome.
And I actually made there's these little invention things where you can put a stupid invention, and they're gonna be like, hey, either we're gonna back you or not, and it's like a scam kind of thing. I did this back in the day to acquire water from the atmosphere, and just saying, hey, why don't we just let the sun evaporate the water during the day, and then when it's nighttime, we put a little negative charge on a big panel, because the water, the dew in the air, as it naturally gets colder, is going to produce dew. That dew is going to be attracted to a negative panel.
Yeah, as soon as it starts condensing.
When it does, it hits a hydrophobic surface as a coating, and it rolls off, and you collect the water out of the air.
Yeah,
at night.
I
called it dew water.
That's part of the reason I'm working on a system like this right now, because I really see power going to be an issue.
Do a dew water. You could easily put a negative charge on that too. And it's cool because nobody's seen it at night. Just be like, hey, just wait.
Well,
I sleep.
Well, I got my Vortex water machine in the locker as well, so I'll be doing my structured water again. So
nice.
It's all based on
that's real cool.
Schauberger's. Yeah, I've learned it from an old friend of mine. He's been doing it for years and years, so I've learned a lot off him. And he's got validation now. It's a couple of universities on the water. So he's trying to sell it now.
Say something about that.
Well, I'll put it to you this way: I've done some interesting stuff with that water. Like the saturation rate of the water is a lot greater. So it takes like half the water that you need to water, say, a crop. This guy in Australia is actually doing this on a very large scale. His water consumption is like half of what it used to be, just by using structured water. And he's getting better results. The fruits and vegetables are big, more lush, healthier, So, there's
combine that with Gerald's electric culture.
You beat me to that punch. That's what I was going to say. I was if you go 1-2 punch on it, you have plasma.
Imagine
seeds, and then you run it through the electric culture, and then you have the structured water.
Right.
Imagine this just for electroculture idea that I want to toss out there, like, because the invention's related on like shaking a sand that's high of silicon dioxide to get a charge on all those granules. You know what I'm saying? So you shake a sand to get the charge on these little bitty granules, and then you dump it into a flower bed that you want to test, and then add the water because it's pre-charged. You know what I mean? So let's study what little shaking sand does whenever you add it to a bed. And
I've even dabbled with Wilhelm Reich's Oregon accumulator. I've made an accumulator box.
That's
so
cool.
I've worked with that. if I get the time this summer,
they call it metal organic frameworks now. It just pisses me off. That's, you know what I mean? They call them MOFs, MOFs. That's exactly like Wilhelm Reich was like, dude, I didn't call it a MOF, but you can call it a MOF, metal organic framework. We've literally twisted his technology into that.
Yeah, and
nobody gets that. Like we just stole it from Wilhelm Reich and put a technical label on it.
You know
how? Hey guys, good night. By the way, wanted to stop in and say hello.
All right,
good night, Joe.
Catch you next week.
Yeah.
Good night, Joe.
Night, Joe.
Yeah, definitely. Like Wilhelm Reich, he was a huge target for the FCC, or not FCC. Sorry, the FDA. They went after him like crazy. Hey, Bernie.
Hello. My apologies first off to Jarvis for last week. I was a little over.
No apologies needed, my brother.
Paranoid, but
you're my man, dude.
Love you all. Love this team.
Bernie. Nathan had an interesting
I feel for you, dude. I feel for you, but you did the right thing, man. Just coming clean and just being honest and giving it out to the public. I mean, I think you made the best move there. Trust me, you're my bro, dude. Like, you never have to apologize. You did not do anything wrong.
What happened? Some scientific disagreement or what?
I was just a little overly cautious and paranoid.
At least it was backstage. Mine was public.
Oh, Bernie, you don't have just say yes or no. Did you get a hold of the guy that you were looking for?
Yes, but then now haven't for a couple of days. So I don't know. Should be okay. Should be okay.
All right. So you're okay. You're stable, right?
Yes, sir. Yes, sir.
Okay, that's good. We don't have to pull out the rubber room, right?
No, definitely not. No. Caught up on sleep, so good. Less
nice.
Less paranoid for sure.
May I say something, Bernie?
Of course.
Be careful whenever you're using the salt water on the spontaneous reaction that you're using with the coil of metal. Whenever you use sodium chloride, it can outgas hydrogen chloride. You know what I mean?
Yeah, absolutely. And I've got a whole bunch of litmus paper tests, so I always check to see what the reaction is and
awesome sauce. Good.
When acidic, because it goes both extremes. Both. I
just wouldn't want you to fill your room full of hydrogen.
Right.
You could use sodium chloride as a base, as like me and Faraday were saying. Maybe alkalines are cool to explore too, because the outgas would be CO2 instead of hydrogen chloride.
Yeah, I don't know if there's been, I think maybe just gold with silver does the hydrogen chloride. The rest, the reactions go extremely alkaline.
Use nickel, Edison battery.
Are you showering?
Faraday would know that. Nickel's a good.
Yeah, nickel's good. It's you have to experiment with the stuff. Like I always say, experiment. If you're second guessing yourself on it, experiment with it. Try it out. Don't rule anything out. Nothing. Even if somebody out there says, "Oh no, it's not going to work," try it out. Do it for yourself. You have to see for yourself, right?
Oh, yeah, even if Jack Sarfati says no.
Yeah, especially if he says no.
Oh man,
because he's always gonna call you schmuck at the same time.
A schmuck-a-duck.
Oh, the schmuck comes after you experimentally prove him wrong, of course, right?
Yeah, I think it comes every time he opens his mouth. Is what I think happens.
Dude, me and Phil would debate him. Like me and Phil, like, okay, what you got, man? What physics are you talking about?
I already killed him too. I already put the nail in the coffin this week. So he just stopped replying for good now.
You gotta send him that picture of you flipping the bird.
Oh, there you go.
I'm just gonna scoot out. I'm just gonna scoot out for a quick smoke. I'll be right back.
Roger, Dodger.
Oh, Jack's the funny.
So Bernie.
Yes, sir.
Well, I don't want to say I'll talk to you backstage, but I would like to talk to you backstage too.
Absolutely, we shall. And
dude, what happened to your room, Bernie? It looks all smoked out now.
That's
your camera?
in direct sunlight going into the camera.
Okay.
There we go.
Oh,
I'm
dude, wow.
Dude, going to the happy place early. I'm thinking
it looked like you had some.
I'm getting taken away. The aliens are coming.
You got
There's
fog going on, man. He's using the CO2. He's using the sodium carbonate. Get some CO2 now. But like you gotta know, like hydrogen chloride, you don't want to fill your room with that. And I'm just trying to be honest.
100%.
Because literally, like, dude, these alchemists would die back in the day fucking with mercury, and they didn't know what mercury could do to you. You know what I mean? It's a science that you have to have somebody teach you with, that you can't go willy-nilly, because you could literally die if you do the wrong thing. You know what I mean?
Big time.
Seriously.
And I kind of forgot to put little disclaimers on some of what I released there, especially with the process of working with lead and tungsten, and how just poisonous lead becomes in the monoatomic state when you break it down in electrolysis. It's extremely sketchy, poisonous, and you will harm yourself quite quickly.
And it's like in alchemy, you just learn lead into gold, and lead is dangerous, like Bernie's saying. Like, so if you're just trying to mess with lead just to get going, and you don't know what you're doing, dude, you could die from that lead. It's plum.
Very quickly.
You know, it used to be that, and that's why you ingest it, you inhale it, or anything like that, you're done. You can do that with mercury too, you know, and that's why it's scary, because mercury is important in alchemy. But if you don't know how to use the mercury, you're dead.
Wow.
Yeah, but don't use mercury, use gallium.
Yeah, but it's not going to be the same alchemy. I mean, when it comes to alchemy, you know what I mean?
Oh, yeah.
Gallium is like 1970s. But gallium's cool as a liquid metal. You could like spin it in one of those things I showed in the past on Nathan's channel. Instead of spinning an electrolyte through a magnetic field, you could spin gallium or any liquid metal through a magnetic field, and you can get what I call a fluid turbine. It's a Tesla fluid dynamo. Sorry, I always call it turbine, but the dynamo would be two magnetic fields. I showed it on Nathan's channel whenever I first. But if you use liquid gallium and spun it above this magnetic field, it would act like a Faraday disc going above a magnetic field, and you get a really high current. You know, and what me and Sean are trying to work on is how to increase the voltage of that current, because you could do it with electrics very easily. And then you have a hybrid system that's high current, high voltage, and you know.
Then you fry your eggs on it.
I wish I had the actually YouTube. I would put like the fireball fry your eggs.
No, but yeah, I did the same, and it creates a gravito-electromagnetic field that shifts the gravitational acceleration. So it shifts the weight of the apparatus.
Have you seen gosh, what's his name with the SR3B or the TR3B? Have you heard about that?
Yeah, the Lockheed Martin TR3B
Aura.
Yeah.
Like,
that's the TR3A, I think the Aura was. The TR3B.
Yeah, you're right.
Is
the B, the A was Aura, and the B is, I don't know.
The B supposedly uses both T. Townsend Brown's electrogravitic charge, but also apparently the three red like plasma balls or whatever on that are seen on it supposedly are
Booty balls.
somehow acoustic generation of anti-gravity.
I think they're booty balls.
Yeah, it's just some sort of plasma, like high energy plasma that creates a gravito-electromagnetic field that shifts the weight of that creates a differential in the energy potential, which will induce a force.
Yeah, and to be able to potentially make a dominant monopole that's positive or negative is cool too, because you can't do that with magnets. That's what separates the invention. You know, because you can have a dominant positive charge or dominant negative charge using the knowledge of that, and you can't do that with magnets. But you can literally have a positive and negative pole. Dominant, not totally.
Yeah, you're talking about canceling energy, or
no? I'm saying when it comes to energy, we can define it as the electron volt on the quantum level, right? The electron volt literally is a charge voltage product.
Yeah.
So the energy is equivalent to the charge and voltage. Okay, that's potential energy.
Yeah.
You know, of the electric field. You know, the energy of a magnetic field is different.
The energy of a magnetic field is the energy density is the magnetic field squared divided by the permeability of
in engineering it would be Li squared. So yeah, I would say, but the L is the inductance. Yeah. When it comes to electrical engineering, that's all I really relate things to.
You're an engineer?
Yes.
Oh, cool. Electrical engineer?
Mm-hmm. Yeah.
Oh, nice.
I have a bachelor's, you know, and I've been studying this for like 20 years, you know.
Just the mechanical engineers know a lot of stuff, so
yeah,
electrical engineers are kind of even better.
Yeah, it's fun because, you know, it's not thermodynamics, it's electrodynamics. It's completely different. Mm-hmm. And to have an electorate is going to change the world, just like the magnet. And I'm just saying, to have these combinations that are available, and if I could work with Mike Faraday on his cell, we'll make as much power as we need, guys. Like, you want to power your house, me and Mike will work together and do this.
Are you next to Toronto?
I'm in Georgia.
Georgia, yeah.
Yeah, you're Georgia, about 3 hours away from me.
The swing state. The famous swing state.
I never heard
that. So what, a 3-hour flight from Toronto to Georgia?
Oh yeah. But we don't have to be in person. We can, you know.
Oh yeah, we do on Zoom call or whatever.
That's what we're best at, anyways. I mean, we've been doing it, so.
Yeah, it's we'll definitely chat offline for sure.
Can I know you guys already seen my experiment, but can I show I show him my experiment I did about the equipment, the MHD vortex?
Yeah, pop it up.
Just one sec.
Right.
Can you see my screen?
Yep.
Yeah. Ah, man. So look on the right. You're gonna see the weight of the apparatus shifting right there.
Mm-hmm.
Yep.
Now I turn it off, and it's.
You did this well over a year ago, I think, right?
Yeah.
You did that, Phil?
Yeah, more than a year ago.
That's cool, man. I like that.
Was this one of the ones you presented at APEC?
No, I got sidelined at APEC exactly at the moment where I created that stuff, and I figured the strong nuclear force and things like that. Tim decided to go all mainstream, so and he can even if we ATM people started APEC, we kind of got sidelined in, in favor of mainstream people. So,
hey Bernie, do you mind me asking why you protested APEC that time? And I had your back, dude. I was in the chat with you, like, hey, if Bernie doesn't like this, I don't like this.
Yeah, it's exactly what Phil's stating, and we discussed it a few weeks ago too, and agree also with what Nathan and Mike feel of how it's like they just take the ideas from presenters, sideline them, and then try to kind of claim them as their own, while simultaneously anyone with real breakthrough stuff they just push off to the side, it seems, lately.
I think this is the best way to do it.
Not only that, they got the guy with the sweater that bores you to death with the fireplace. Oh my god, dude! I can't sit through that, dude. I turned it on and off several times last time, and I just couldn't do it. I kept falling asleep.
What? I mean, it's hard to keep your attention. I mean, who wants to sit there 4 hours of like where you're like, dude, is that really the best you got? Like, what could thrill me at least? I mean, give me something. But there's nothing at the end of 4 hours, and you're just like, dude, I just feel like I wasted 4 hours.
I'm curious about something. Why are they not recording anymore the stream, like the Zoom meeting? But
I don't know. I offered to do so, and they said no, and I don't know.
Well, I'm there with you, man. I'll protest, Bernie. Are you still against it?
And I think it's too many egos.
Yeah, I just hope that they reopen up the platform a bit more. I guess they were attacked by a bunch of trolls or something at one episode or one session, and then they closed it off and have limited a whole bunch, and it's not the same as it used to be, and I just hope that they reopen their format more.
Or we can just keep doing this and like blow APEC away, because this is the real engineers. I haven't met any other extraordinary inventors in the league.
Yeah,
nobody else is doing what we're doing. I mean, APEC can do APEC, but like this is like a group of real engineers working together and making it happen. So,
well, it's, we're not basing all our stuff on ego, trying to make the mainstream media, right? We're just trying to do our own thing.
Yeah, that's why I like working with engineers, because there's no ego, and if it works, it works. If it doesn't work, it doesn't work, and you have the ultimate last word. The theoretical physicists can say whatever they want, but you're the one who's gonna find out if it works or not.
Yeah, experimentation will always trump the physics.
Yeah.
Well, physics comes later. I have a theory on why they split it. One is being recorded and broadcasted to the world. The other one, they're just stealing ideas from, and there's no proof of it.
China?
That's the truth, because look at the people that are on the
China's going to take my shit. China's
going to
take
people that are not on the live one.
Lulu knows a lot, because she's.
Can you gentlemen hear me?
Yeah.
Yes, ma'am.
Mike does.
Oh, thank you. Thank you very much.
Ooh, Winona Ryder's back on, dude. Dude, I had to call you, dude. I know your name's Winona Ryder, but I assume you're a dude. I'm just gonna.
Thank you, man.
Thanks, dude.
Yeah, live chat is alive and well. That's what I like about our show. You know, we have a really good active chat board, and welcome anybody that's new that comes to the channel. Welcome to our show, and this is who we are. We're trying not to be egocentric maniacs. We're just inventors that like to shoot out ideas and share our ideas, and hopefully that can help one of our other followers advance in their stuff. That's what this is all about, right?
No, but that's exactly what I said to Jack Sarfati this week. I said, I told him that all he cares about is selling books with his and disinforming the population with his nonsense. And proof is he wouldn't bet $5 on his experiments. He wouldn't because he knows it's not gonna work. It requires exotic energy and all that nonsense. So he clearly knows it's never gonna work. What he's talking about. So he wouldn't spend $5. He can make all the calculations he wants. But
Could I offer an experiment off my physics that would work? Maybe. What if Sean makes this electric pendulum, and can a control neutralize weight to swing it, but like a positively charged electric and a negatively charged electric compared to the neutral swing? Do you think there would be a difference in the time of the swing? I think there would be, because the Earth has a more abundant negative charge. And if it's a positively charged pendulum, it would have more acceleration towards that. So I think the positive pendulum would tick faster than the neutral. And I think the negative pendulum would tick slower. And that's
you're right. The Earth has an electric field, so it's
when it comes to physics, the power is prediction. You know what I mean?
Yeah.
When it comes to potentials, no matter what, the more positive potential is going to feed the lesser potential. No matter what.
Potentially.
No matter the circumstance or material or whatever, the more positively, the greater, not positive, I shouldn't say positive, the greater potential is going to be the source to the lesser potential, no matter what the circumstance.
That's why it'd be interesting for a pendulum just to see,
By the way, hi, Mike.
Hey, what's up, man?
Nice to see you, man.
Well,
no cameras.
It is good to see you.
He's still in the holodeck.
If my picture's not good enough.
It's 3 holes.
Gives me every time.
You'll never live this one up. Especially.
Oh, we played the episode with you in it today, Mike. With the big toroid, the giant transformer you had with the 6-inch hole. Remember that? He's all proud of it, showing it off, putting it right on his head, and he's got this big hole.
I mean, coil.
Yeah, awesome coil, by the way.
Yeah, the big hole coil.
Yeah.
Oh, I got something to show you. I don't know if you've seen this.
12-inch diameter.
So you're going to talk a bit about the diode aspects, right, Mike, and how it's crucial in engineering.
Okay. Tesla did it first with the selenium diode, okay? And what he did is he made this selenium panel, like a big selenium panel, aimed it at the sun, and cosmic rays would evaporate the charge off. And that's the photoelectric effect. And Einstein took the Nobel Prize for that, but Tesla made it, okay? He took this big-ass selenium panel, aimed it towards the sun, and made a diode that way, because it's one way direction towards the sun through the selenium panel. We would call it a solar panel, but Tesla was the first one to show the photoelectric effect when we say that Einstein got the Nobel Prize for the photoelectric effect, but Tesla discovered it. Cosmic rays.
Oh, I love
That's
it.
Mike's big hole.
Oh, got a mighty
Wow,
big
that
hole
looks-
there, Mike.
Mike, you're muted. Faraday, you're muted, sir.
This thing weighs like 20 pounds or more, 25 pounds. This thing's heavy, man.
That's a
Look
heavy
at, the
hole.
size look at that heavy hole.
You can use that for a workout.
Yeah, you could work out with the damn thing. It's heavy.
Is that like true barium or no?
This one is a ferrite core, heavy as all hell.
But not barite. But that's okay. I mean, it's hard to find barite, right?
Yeah, this is a monster.
That's dope,
Oh
though.
man, did your hand fit through that hole?
Probably.
Are you
close
gonna
to
make?
it.
Oh, you're making
Let's
him
do
fist
it.
the hole. Oh my!
Oh my gosh.
Mind you, I have a very big hand, so.
Oh, the very heavy hole.
Some people bigger than others, huh?
Yeah.
Yeah.
Oh man.
Oh,
What if you put like gallium or mercury in the center of that hole while operating it?
Actually, know what I have done. I put my Tesla plasma ball and rested it right in the middle of the toroid, and I was able to light off light bulbs with all these leads.
Were
Oh,
they
nice.
LED? Were they LED or
Yeah, either or.
okay?
So I just
Incandescent? Could you do incandescent?
if the plasma ball was say 5 kilovolts, maybe. But
That's
the one
dope.
I have,
Yeah, that's
But-
where you really test, though. You know, if you're really extracting
But yeah.
stuff.
like they're groups in two,
That's
so
cool.
I got 1, 2. There's
That's
four sets coming off it, and I've got them all labeled. Which one's more powerful than the other? You know, the resistance and all that. So I could hook it up to any of these leads, and if I had the plasma ball even just beside this, it picks it up.
you know, Mike, I got one of those. I pulled it out of a speaker. It's just not as big as yours. My hole is much smaller.
I got the biggest hole of them all. Oh my god, sorry.
Like
Going
a
off
holy
the rails,
rollers in here.
man.
I'm sorry, man. I got to make some jokes, dude. I've had a hard day. I burned my mouth off today on some hot wings.
Yeah. Take a screenshot of that.
Nathan was a trooper, man. Is it like you said? You got some blue eyes to tame it down.
Oh, gee, it was bad.
Have you guys seen where they do 2 wirings on those with the ferrite core now, but separately halfway? And apparently by having them 50-50, you can actually like pull some like extra
You're
energy
mirroring
out
it.
of it, something like
So if you had 22 turns going on one side and then 11 and 11 on the other, the amount of turns are the same, so they resonate back and forth to each other like a mirror. But the beauty of splitting it on the opposite side is you can use the 11 to go run off to your regular system. Then the other 11 is a multiplier. It's in addition to it. So what you're doing is you're making a half wave.
Yeah,
You know what I mean?
half-wave.
Yeah, in the whole thing, and you're able to pull the energy for free. It's
Yeah,
called
the other-
a bit.
Right, a bit transformer. Yeah. So what you want to do too, the one that is your half wave, you want to go to a bigger gauge wire, and you're gonna wind it in the opposite direction of the one that's drawing power into it. All right. So what you're gonna have is a decrease in voltage, but your amperage is going to go through the roof, and that's what Don Smith was working on. This is all what ties in what he was doing.
But on a ferrite core, though, I want to say this. I don't think it's working exactly that way. Don Smith was working with coils, which it worked perfectly to pull out the amperage. But the ferrite core, because of the way it is, I don't think it's going to give you that.
Yeah. Yeah, because I know he worked with toroid cores like this. He made one device that had two of them, not as big as the one I had. I think they're maybe about 4-inch diameter. This one here, I think, is 8-inch diameter. So it's hefty. It weighs a friggin' ton.
Yeah, it's you know what? Where you find that toroid, by the way, in that configuration is in the jewel thief circuit.
Yeah.
That's where you're going to find it, because you're all about saturating the core at that point, and then it's resonating back and forth. When you hit that resonating mark, then you can amplify things. So I found it in the jewel thief.
Yeah. Yeah, definitely. A lot of you can. I played around with this thing quite a bit, especially with even with the Renegade device. I was actually able to split the power off and get more, two channels with the same amount of potential coming out of it. Right, so right there, that's over unity right there. If you're splitting it and still getting the same potential off each channel, then yeah, you're ahead of the game, right? But yeah, the plasma stuff I was doing with this, actually, I was surprised it worked as well as it did.
Well, yeah, I mean, it runs through there pretty good. You actually probably get a conversion out of it. Just putting a voltage field in there, like a potential, and it'll probably pick up amperage because of the toroid.
Yeah, because it's a closed circuit, so it's just gonna hold that electromagnetic field. It's different with if you're using like say a solid rod ferrite core versus a toroid. A toroid is a closed magnetic field, right?
It's closed circuit.
Hey Faraday, do you mind if I ask you a question?
Sure.
What do you think, like a mylar balloon, if you were to spray it with some of that carbon conductive or nickel conductive spray, and then like sprayed it with some vinegar, like as an acid, and then send it up as a balloon with like an aluminum wire attached to the earth? Do you think the evaporation of the vinegar on the balloon would increase the current from the balloon earth path?
If you're using graphene, you won't need it.
Well, do you get what I'm saying?
Yeah, I understand.
You could also do it with sodium carbonate or whatever alkaline you wanted to try.
There's
you're spraying the outside of it and then lifting it up to get the potential and seeing if the alkaline spray around the outside or the acid spray around the outside will give a current that's stronger with the potential, because it's evaporating off into the atmosphere, so it's pulling the current through the earth if you sprayed it.
Yeah, that'd be an interesting experiment.
Right? Doesn't that sound cool?
Yeah, like
I had like this idea of like a fishing rod where you'd be like, those old fishing rods where you hit the little button and like let it fly out. So you just hit the little button and let the balloon go up.
Yeah.
And you charge these bobbins, and when you fish, it's cheating. This is like if the power goes out and you need to eat. You can make these shock bobbins where the fish will bite it and they get shocked and come
shocked.
Don't do this because you will be arrested and it's cheating.
Kind of like dynamite fishing.
Yes, do not do
same thing.
M80s. Don't do that. That's not cool. It's survival only.
Yeah. Get the Canadian Parks and Recreation on your ass.
But yeah, it would be a fun experiment, like with a fishing pole. But you have to have like the reel made of aluminum wire or something light.
Yeah.
Take the mylar up and then test between.
Yeah, what I like to do is get a helium balloon, like you're saying, and spray the outside of the helium balloon with graphene spray.
That's what I was saying. Like spray it and then put like an alkaline or an acid coating on it.
Yeah, bring it down to a gram potential, and you can run like an atmospheric motor.
Mind if I ask Jarvis a question? What's the what do you know about this acid and pH values? Raising altitude. And what's your concept on that?
Think of alkalines as electron donors, and think of acids as electron acceptors.
Okay.
There's
okay.
acids like to absorb electrons.
Uh-huh.
Alkalines like to give up electrons and become earth metals. You know what I mean? Alkalines are more earthy metals. Okay.
Actually, Jarvis, know what you could experiment with? Ultrasound gel that they use when you get an ultrasound. It's a gel. It's highly conductive.
Mm-hmm.
Put that on the surface and see what happens.
So wait, if acids like to receive electrons, is that correct?
Yeah, acids have a potential to be like a sponge to electrons, and alkalines want to give them up readily. Especially like bentonite clay is a naturally negatively charged clay, so you can use ceramics too that are naturally negatively charged, and then you use an alkaline to knock these electrons off because they want to go. Nature is not that difficult. Nature does its thing naturally.
So correct me here, is the higher the altitude, the more protons you're
more positive compared to Earth.
Yeah.
And the lower the altitude, you're reaching electrons.
Yeah, it's approximately 120 electron volts per meter.
Wait.
Yeah.
Hold on. The sun is the protons, right? Right.
Protons can be alpha particles,
Well, the sun doesn't release electrons, does it?
Yeah, the sun is an alpha part. Like Helios literally was the sun's name, and helium is named because the sun emits helium.
Well, helium is a hydrogen
in a positively charged state that's called an alpha particle, and that hits our ionosphere and strips away our ionosphere and makes it positive.
But isn't helium a hydrogen type?
This is like Tesla wrote a book on gravity, and this is like,
Question: isn't helium a hydrogen type?
Helium, if it's stripped of its 2 electrons, is an alpha particle. Yes.
Well, I mean, that's not the question. Hydrogen type is hydrogen. It's based off hydrogen. Helium is a form of hydrogen.
You asked about helium. Helium, yeah. Once those 2 electrons are stripped,
helium turns into hydrogen, or vice versa.
it turns into an alpha.
Well, me and Jeremiah were able to replicate a process of transmutation that turned hydrogen into helium. But yeah, helium is double hydrogen's atomic mass.
Right.
Yeah,
and it doesn't. And let me get back to the protons now.
An alpha particle.
And getting to protons here, hydrogen is proton based. It's primarily protons. No, I mean there's not a lot of electrons.
Hydrogen is a single proton.
Correct me if I'm wrong. Is there a lot of hydrogens in protons, or is there a lot of electrons in protons?
There's one proton.
One electron in hydrogen.
Say that again.
Hydrogen is 1 proton and 1 electron.
Oh, so it's even.
Yeah. If you got deuterium, then you got a neutron with the proton with an electron on the outside, but that's the deuterium. And then you get tritium isotopes.
Deuterium is more protons, less electrons.
Yeah, man.
No, neutrons. The protons stay the same.
Deuterium, yeah.
The atomic.
Well, neutrons are just irrelevant here because they're neutral.
Yeah.
Neutrons are what form the isotopes of deuterium and tritium.
Tritium, yeah. See, Bernie, he's an alchemist, so he could like chemistry and alchemy is similar, and alpha particles are emitted a lot from the sun, and those are literally a helium atom that are stripped from its 2 electrons, and that hits the ionosphere, strips away the 2 electrons, and leaves the ionosphere positive.
What's stripping it away?
The electrons. Alpha particles that are emitted from the sun, which are helium. Helios is the sun. Helium was named after the emission of helium. Whenever hydrogen combined into helium and is released by the sun, it's literally helium, but it's particles that are positively charged called alpha particles.
And the ionosphere is stripping the electrons?
The alpha
Can you see my screen, Joe?
There we go.
So the ionosphere is stripping the electrons.
No,
So that's a hydrogen right there, Mike, and that's helium. You know, you have 2 electrons rotating around 2 protons and 2 neutrons.
what happens is that helium atom is gone from the electrons and ejected out of the sun. So it has a positive charge overall. And when it hits our ionosphere, it takes another 2 electrons to try to even out, like this looks like. So as it takes those 2 electrons from the ionosphere, it leaves the ionosphere positively charged compared to the Earth's potential.
So the ionosphere is donating the electrons.
Yeah. The ozone layer has a lot of electrons.
What's donating the electrons to the ionosphere? The Earth.
Yeah, 100 lightning strikes a second.
The Earth. Okay.
100 lightning.
So that goes back to what I was saying. The Earth is primarily electron, and the sky is primarily protons.
I don't disagree, but I'm saying why. You know what I mean?
So you said acid absorbs electrons.
Yes, it's like a sponge.
So why would you put acid up there if the up there is primarily protons? You would put alkaline up there.
As an experiment, 2 balloons with 1 acid and 1 alkaline would be interesting.
Well, I'm thinking the alkaline would be the one, receiving the electron.
Yeah, you create a potential difference between the 2.
Oh, you could get the world's largest Jacob's ladder going on with that.
Yeah.
Just hope you have a very large capacitor bank to capture that stuff.
Yeah, I'm just saying, like, why not try?
It's almost like the Earth is converting protons to electrons.
Experiment.
Philip, what is the heaviest element you can model in your software? The one that what is the heaviest element you could do?
Be right back.
Good question. Let me check.
Oh wow.
No, but that's I need to check the let me check the
I know gold is up there. Gold, lead. Gold and lead, I think, are right up there as far as the heaviest elements.
They're all radioactive, the heaviest, but
probably the heaviest.
Bismuth is cool too. I think bismuth is easier to turn into gold than lead.
They're all in the same line.
Oh, remember, you just said it. Remember, I was talking about that non-silicon based. It's bismuth. They're making the silicon chip with.
Bismuth without really the silicon. Cool.
Yeah, bismuth and graphene.
It's diamagnetic.
The heaviest non-radioactive one is called organicin.
Okay, and what's
interesting?
Organicin. Sorry, I missed the.
So you could
terminology.
What's the atomic number?
118. So you can simulate 118.
Yeah, but I don't think anyone's ever synthesized that. They have a very short half-life on that.
It's heavy.
No, it's not. It's not a radioactive element. That's 118 right here.
The noble gas.
Oh, okay.
All these electrons and protons adding to the heaviness of an atom. It's all just potential. So it's just potential heavy.
Energy density.
I mean, it's not real. It's potential. It's just,
energy density. Energy is literally the charge and the voltage of an electron, like at a quantum level. All you need is charge and voltage, and electrons exist everywhere. So unless you say that electrons don't exist, I'll say that energy is free, because I'm breathing in these electrons that are perpetually part of atoms that you can't destroy.
Electron exists, but it's not a particle. It's just a virtual
particle. Like free energy, I hate that, because all energy is free. You know what I mean? What we get to exist right now is like breathed in by these perpetual motion little atoms going on.
I forgot.
Well, it's
they
like,
don't exist.
it's like
Yeah.
breathing in air. Without air, okay, you have consciousness. If you don't have air, you're unconscious. Get it?
But
You have to
Yeah.
consolidate
you,
potential
you,
to get heavy.
you'll agree with me that if you create, there's a lot of ambient energy around us.
It's
But if you
everywhere.
create-
It's free, dude. Everywhere.
We're
Yeah.
swimming in it.
We're
Yeah.
just like
When you look at
But-
most of space, is just
but we
hydrogen.
can't
And hydrogen
harness
is the
it.
most balanced.
we
One
can't
electron, one
harness it
proton.
because there's no potential. So we need to create a void, a real void. That's going to create a potential, like a differential, and then it's going to create a force we can harness.
that's
we'll
why
be able to create-
electrics will play a part that's
Yeah.
different from magnetics.
Right.
It's all about consolidating
Yep.
the balanced potential that's everywhere into a smaller area.
Yeah. Either
Once
it's
you
like
start combining electrics, like the world's gonna be completely different.
See, that's why I made the power cell. That's exactly what we're talking about.
And that's why I want to work with you, because I know where you're
Consolidating.
going.
So
I know where you're going, and I know how me and Sean can help. You know?
Mike is stealing our ideas and making profit of it.
Right?
I don't think so.
Oh,
But-
funny.
But,
How do you,
but you know
how do
what?
you use the bismuth, if you don't mind me asking?
Sorry, bismuth in
How do you use that?
what
In
in,
your
my
cell.
cell? I don't have bismuth in the cell.
Okay, never
But
mind.
the
but,
diode is
this-
like a consolidator.
Sorry.
Well,
I went
well
off
the
that.
diode, well, the bismuth, it can be used in. It's actually in that diode that John Hutchison was working with.
Gotcha.
Yeah.
Okay.
So you got bismuth, you got barium titanate, iron oxide, and there was one other element. It eludes me now. I'm trying to remember the name of it, but it was like 3 or 4 elements inside this diode, and with nothing going in it, it's not connected to anything. He was getting a quarter of a volt, constant
Yeah, dude.
potential.
Yeah,
I
that's
saw this
interesting.
guy. Did you see this back in the day, Michael? You probably saw this, where he had this like black looking rod, and he put 2 probes on it, and it lit a light bulb.
Yeah, that's this
And
power
he-
cell technology.
I saw that.
Yeah, and he was saying it's aluminum bismuth alternating layers.
And he
Yeah.
also-
You can't find those videos anymore.
Yeah, they're
No,
hard to
I-
find.
Yeah, I got a couple of them. I was watching one today. He also has barium titanate wafers in there. They were, I believe, a 1/16 of an inch thick, and they were about 1.5 inch diameter. He had like 20 of them. It cost him like something like 30 grand.
Barium
Wow.
titanate is a really interesting electric material.
Yeah, I got tons of it. I've got barium titanate.
It's hard to get. That's awesome. You can get it.
I have about $3,000 worth of this stuff right now.
Well, I mean, Sparky Sweet thought it was cool, so I think you're on the right path, brother. I think like I said, if we understood what we're doing together, we could really do this.
One thing's for sure is these metals, you can't combine them without separating them with a neutral like carbon or something, because they could eat each other away,
That's what I have in the cell, carbon.
I could say something, but I don't want to give away anything.
That's how they make diodes. They got the, one metal,
Carbon
then
layer.
carbon, then another metal of different metal, and then carbon, and then another metal of a different metal. And
I like
that's
the way
how-
you think, Mike, but I just can't comment.
That's how they get the
Off
energy to
mic.
go in one direction, not back the other. They have to use less conductive metals from left to right as they go along, and that's in that same way. The perpetual energy diode can be manufactured, technically, if you know how to combine the metals right, with insulating in between them. You have to. Or you don't have to if you're
It takes
able to
a
combine
lot of
them in
thinking
a way
about
where they don't eat each other away,
this.
you know.
Honestly, like, you're not gonna just. I feel bad, but like, I've thought similar maybe 5 years ago. Like, and imagine me thinking what you're thinking now. Where I'm at is close, and I congratulate you for thinking like that, man. But I can't comment on how I would do it. But just keep thinking about it, and you'll figure it out.
Yeah. Well, what I'm thinking is you got to find the right. Let's start with two metals. If you find two metals that don't eat each other away, now you got to find a third that doesn't, corrode the second, and then a fourth that doesn't corrode the third, and so on. And if you can layer them like that without a carbon insulator in between, that would be my thinking as the way to do it, because the carbon is going to.
How do you think the Earth does it?
Probably it's like that, yeah.
You think something similar?
I mean, there's carbon all over the place too,
Absolutely.
So I don't think.
But just like I always say, like if you think of something that seems more complicated than what the Earth can naturally do, you may want to rethink it, because the Earth.
Well, actually, I'm thinking the Earth is not actually doing the production of the energy; it's doing the conversion, and that the celestial bodies are creating sounds that do the vibrating, and that's what creates the energy, is the sound. And the Earth is not creating anything; it's doing the conversion. It's converting the sound into energy.
Well, when I say Earth, I mean nature in general.
Yeah.
Yeah, I just did a voltage test on this cell that I just made, the new design. It's putting out 2.52 volts.
Like the whole space is where the sounds are from. The combination of bodies out there, moving around or creating the sounds, that you can't necessarily hear, but they're there. And the Earth is converting those sounds into waves.
Is the 2.7 volt, is that a solid state?
Yeah, this is a solid state. Yeah.
I love the solid state. That's cool.
Converting the waves.
They measured Saturn's rings. They had this detector. They wanted to hear the sound of Saturn's rings. Saturn's rings were stable, but when they measured it, they destabilized the rings. So when they remeasured it, it was different from the first measurement. So it told them that by trying to read, the sounds, it altered its state. It collapsed its function. So it disturbed the ring system. So, sound does affect. So imagine if you're localizing a high energy beam in a local area, yeah, it could destabilize it. It could even.
How did they know it disturbed the state if they can't listen to it? They had to do it visually somehow to see the disturbance.
Whatever that machine that they used, when they converted it, to see it visually and hear it, there was a difference between the first time that they took the measurement and then the second time. So they knew that they were the cause of that disturbance. That machine is that powerful.
Oh, so the machine had to beam out a laser or something to.
Exactly.
I see. Okay. Well, of course, that laser is going to connect to the ring of Saturn and bring it that vibration through the laser to the planet Earth, and that's going to definitely change the resonance going on with Saturn as a single unit. Once you send a laser out to it connected to another body, then it's not a single unit now. It's two units combined. A light may not be a wire or a physical wire, but it's still a connecting medium.
Bernie disappeared on us.
Sorry, just looking for my external hard drive. Just need a minute.
So I've built 4 of the new cells on the new design, and I'm getting about 10.63 volts, and it's been running pretty steady. I took this one off the stack just to measure the power, and I'm getting a steady 2.5 volts out of the cell. My old cells were only putting out about 1.6. These are like almost double the voltage.
And you don't need to feed it no power. It just
Very
puts out the
nice.
2.5.
Just runs on its own, man.
Nuts. That's the barium titanate.
No barium titanate in this. I can't really talk about what's on the
Graphene.
inside, but it's got a graphite plate. Yeah, that's the main conductor. The charge, whatever charge is coming through that median, is going to gravitate itself into the graphite. So
You know,
it has capacitive value.
You know what I think's an interesting material, along the lines of what I think you're working on, Mike? Pyrolytic graphite. I know you probably looked that up.
Yes. Yep. I already know what that. I know exactly what you're talking about.
It's cool, right?
Yeah.
Yeah, I could see it being useful. Are you?
Well, the
Sorry.
Go ahead.
Are you using? You're not using graphene. You're using graphite.
Graphite. This is a high grade. This is what they use in nuclear reactor cooling systems.
And that's why carbon's so cool, because you could go from graphite to graphene or diamond, which is not conductive at all, but very heat conductive. Or
See, this one. Yeah. What's interesting about this cell is when you put it under a load, the cathode cools down.
Yeah, endothermics.
Yeah, it's a 10-degree difference between the cathode and the anode.
I want to talk to you backstage. I want to say something, but I can't. But yes.
Yeah.
That's
I
why
understand carbon. It has a geometry of the tetrahedron geometry. Like
it
a
depends
spiral.
on the allotrope, dude. There's like so many allotropes of carbon, and carbon's just miraculous how many things it can do.
So you're saying it depends on the form of carbon and what geometry it has?
Yeah, diamond, is completely different from graphene or pyrolytic graphite, or activated carbon. You know, like there's so many different ways to use carbon.
Yeah.
And it's what you want to focus on is the allotropes, because carbon can be extremely conductive like graphene or a complete insulator like diamond. And between those two, there's so many different ways you can use it. And I would recommend people to look at the carbon cell to understand that further.
But the majority of carbons, even though the geometries are different, they're still relatively spiral. No?
Well, I mean, they're hexagonal, I would say.
Which still has that angle, that 45 or 9, whatever, 27
maybe
degrees.
I haven't looked at the angle. You might be right.
It's the same angles. So when you think about that angle and you think about how a wave has that angle, so there's waves everywhere. Carbon is, allowing the waves that are everywhere to wrap around itself.
Carbon's a miraculous thing that most people don't get. Water and carbon are carbohydrates, the basis of life on Earth. Like water and carbon are very miraculous. Like so many ways you can take water and carbon just, out of any two elements. It's just amazing.
The fact that diamond's an insulator tells me that the carbon in there, the molecules are not aligned.
No, they are. No, they're tetrahedrally aligned.
They're aligned. And how is it an insulator then?
Because it's a thermal conductor, right? So it allows photons to pass. And the cleavage, I guess.
Electrical insulator?
Thermal.
I mean, don't they use diamond in crystal oscillators?
That's quartz, yeah.
I'm sorry, quartz. It's it's similar to diamond, isn't it? Quartz.
Well, that's silicon, not carbon.
It's a carbon. Quartz is a carbon, right?
Silicon. Quartz is silicon.
Silicon. And
silicon dioxide. But it is a semiconductor like carbon. Carbon's in the same, like on the periodic row or column going down. You got carbon and silicon, and then germanium. So they're in the same semiconductive class.
So diamond's not exactly an insulator then.
Diamond is a carbon-based insulator. It's one of the best insulators against electricity, but it's one of the best thermal conductors. It can conduct heat, but it can't
conduct light too.
Yeah.
Light as well.
to make diamonds, it takes very, very high
Well, that's quartz,
pressure of physical pressure as well as heat at the same time. That's why diamond has the properties it does.
But it's still carbon. It's still the same
It's
thing.
still carbon. Yeah.
It's just tricky.
Right.
No, but they have a solution to make diamonds more efficiently using gallium.
That's alchemy, man. I can't say this.
It's material science, right?
Yeah,
I think it all depends on the angle of the carbon.
How about you have a pile of sugar and then you send a balloon up and cause a lightning strike to hit that sugar, and maybe you're gonna get a little bit of diamond out of it.
Yeah, they're combining gallium, nickel, iron, and silicon. Design graphite crucible. Researchers are ushering a new era for diamond production.
Yeah, you can make diamond. It takes a lot of pressure to make it.
Yeah.
No, but like I said, they found an alternative way to do it without high pressure.
What blows my mind? Like ancient alchemist script talk about taking gemstones like diamond and softening them and being able to mold them with their hands and then re-solidifying them.
That's crazy.
Right? Imagine if you could take a big ass diamond or small diamonds and combine them into big diamonds they talked about back in the ancient alchemist days. Bernie, you should know this.
Can you see my screen?
Absolutely.
I don't can do that.
You remember, like, they would soften gemstones and combine them or shape them, and then after they're softened by that process, they would reharden it, and it would just be like the original. But how we adapted it.
I would like to see that.
Yeah, Mehran Kesh actually talks about it and how you're able to create diamonds through the electrolysis process as well.
I think if you're patient enough, you could.
I saw this video on how they made the pyramids. And the theory was that they built a huge Fresnel lens to melt granite. It was portable, but still a huge one.
Yeah, Fresnel lenses are really cool, though. You can cook with them, like melting stone and stuff, but I don't know. I think
the problem with combining them, you wouldn't know if they're gonna stay clear or they're gonna, like go darker. Like the bond right from the.
You would have to like patiently get the distance. Like when it gets darker, just try to level it out and see if it makes the focus better. You know what I mean?
No, I'm saying
I'm just gonna scoot up for a quick minute.
Like remelting it or combining other pieces into one bigger piece and solidifying it.
Gotcha.
Thinking that process. Well, how would you guarantee for it to stay clear?
Yeah,
I think, Lulu, the clearness is related to the alignment of all the molecules so that the light can refract without being blocked. If the molecules are not aligned, the light will be blocked. So that's what I think has got to do with the color of the material. Is the molecules, whether they're aligned or not. They're not going to be aligned if there's not a sound wave or something to align them when they're in malleable form. So once you turn the material into a malleable form, it loses alignment, and if you don't realign it before it becomes solid again.
That's why they had to re-solidify it as the next stage.
Yeah.
And I believe some had aspects to do with mercury too, if I'm not mistaken.
Well, at least Bernie knows that I'm not just spitting spitballs for no reason. This is alchemical text.
Big time.
No, listen, if there's no experimentation with thought of what you could do, then how do you know if something works or doesn't? You have to first think that, what you suggested. Yeah, I mean, how would you know if it works or it doesn't?
Absolutely. I mean, until you literally do it, you don't know. So yeah, it really comes down to that, like believing, having faith in
We
it.
still don't know why the sky is blue. We
You
say
gotta
it's
have the
because of the
faith to
ocean
do it,
water,
though.
but that's
Nobody's
not the
gonna
truth.
perform an experiment for no reason. Like they're like, okay, you can't shape this diamond into whatever you want, or combine diamonds into one big ass diamond, because we believe that that's not possible. You know what I mean? But just like sending up two different balloons, any experiment, unless you do it, you know, but they're so cryptic about the way they say to do it, you know, and unless you know the lingo like Bernie does, then you'll never understand what they're saying. It's just cryptic. You gotta know symbols, you gotta know a lot of stuff. But hey, I mean, who's to say that it didn't? Why would they make it up? Is what I'm wondering. So many different resources saying that you could take gemstones and craft them like that. It's just something that, like, you know, if it is made up, why is so many people making this up?
Aren't they doing that with heat though? Temperature?
Maybe.
The current, you know, synthetic diamonds, they're made with high temperature pressure chambers, no?
Yeah, modern ones, yeah.
Right.
But
that's how carbon is turned to diamond under the ground. You know, pressure and temperature.
Conventionally, yeah. But dude, there's literally this I don't know if I should say this.
Yeah, why not? That's all to me.
Quit. He's foaming. Keep foaming.
You can take carbon dioxide, freeze it, and make dry ice. You can combine it with aluminum powder and make a thermite reaction. In a controlled environment, that reaction will produce microdiamonds. A huge amount of microdiamonds in that explosion. Because when the aluminum reacts with the CO2, it starves the oxygen of the carbon, and the carbon just makes a ton of little bitty diamonds. And what alchemists are saying is you can take those little bitty diamonds and make them into a big diamond. You know, but a reaction is possible on Earth just through they called it a cold thermite, because it's the only time you're using dry ice.
Diamonds, like, you know,
it's a thermite
diamonds if you can make them.
I'm just saying, I can make diamonds if you want me to make diamonds.
It's not, but if you can make diamonds, you're not going to get rich, because then it's you made a diamond. That means people can make diamonds now, and they're everywhere, and they're not.
They're already doing it now.
I'm not trying to get rich off of it.
Different than cubic.
What's the use of diamonds? You know,
drill blades and the hardness.
If diamonds are
not rare anymore,
they're than gold. If you can make diamonds, you would make more money than gold off the weight. I'm just saying, if you literally could make diamonds, you would be the richest person on earth. But I'm not trying to do that. You know what I mean?
Right. Let's say they make diamonds. They have a use for diamonds. That's why they make them. Right. It's not to get rich. They have a use for them.
But they are already available. They're called moissanite. They're lab ground diamonds.
They'll have saw blades that are have these little bitty diamonds that are made by a process that's telling
for saws, right?
And
I know that part.
But price of a real diamond.
It's cheaper to use synthetic diamonds for that than to use.
You're literally making diamonds more easy than gold. I mean, it's worth more than gold in weight.
Okay,
but
so
I'm gonna shut up.
Ones that you can create in a lab are good for tools, but diamonds for the diamonds, they be natural diamonds. But for tools and experiments,
that's one use, cutting blades and all that. But there's got to be more than one use for diamonds. I mean,
aesthetics, because
space,
it'd be cost effective.
Space work,
yeah, but you're
groundwork, tunneling. Maybe they're using them to make these tunnels under the ground. Maybe that's why they make diamonds, because they're making tunnels all over the place, which we know that's happening.
Yeah, but it's supposed to be for for use as in building material, not for the use of what tradition holds of what a diamond is, is valued to compare to one that is
jewelry or whatever
made by man versus made by nature. Like the ones that are made by man is good for the building things, but I
can see why people would want to make gold, because it's very useful for electronic devices.
Yeah, okay, but there should be. because the value would be different. Do you understand? Like okay, let me put it in this perspective. I'm a girl, right? A synthetic diamond would mean crap to me, although it's a
Right.
diamond, but so the value has a difference on to whom is viewing that. From like commercial use, they don't care. They want the synthetic one because it's cheaper instead of being mined and hard, like from
Right.
wherever, like for mass production. Yeah, they would want the synthetic one. They don't care about the natural value of it,
But the
right?
facts are the facts. In the long run, if diamonds are produced like they are today, using them for jewelry is going to phase out. It's not going to be
No,
appealing
I'm not
anymore.
saying for jewelry. No, I'm just saying that natural diamonds, what gives them their value versus the synthetic diamonds? What's the value? Because one is natural, one is man-made in
Right.
a factory. There's not a
Well, if I may say one thing, what would be the difference if somebody did turn lead into gold and say, you know what, this block of gold is made from lead and this block of gold is natural? It's the same question.
There'd be a lot more iPhones.
Yeah, gold is gold. The CERN was able to do that recently. Did you hear
I'm
about
just
it?
saying, you're saying a diamond made artificially has a less value, but they could just hide the fact that it was artificial and say, look, we found this diamond in Africa.
Yeah.
No, you can't hide that. Actually, you can see the difference.
All right.
You can see it under a microscope. What's you call those guys? Jewel smiths, or whatever. They can easily see which one's real and all that. It's got to do with something to do with the I don't know. They can tell though. The clarity, I think, it's not as clear. The synthetic ones are not as clear.
Okay, I will say with vapor depression, like what you're talking about, like the vapor type of diamonds, yes. But the way I talked about it with the thermite reaction on CO2 and aluminum mimics a real diamond, but they're very, very small diamonds.
All right, guys, we're almost at 11:30 here. I think I'm going to square it up. I have to get up pretty early tomorrow. But I'd like to thank everybody that popped into the show tonight. Lulu, Nathan, Philip, Mike, Bernie, and last but not least, Jarvis. Thanks a lot. We go live to air again next Friday at 9 o'clock Eastern and 6 o'clock Pacific. And I hope everybody has a great week and productive week. And we'll see everybody soon.
Good night, everyone.
Thank you.
Good night.
Good night.
Much love.
Night.
Stay on, guys.